So when we're looking at functions, there's a bunch of things we can do with functions. And one of these things is to do different sorts of algebraic combinations of functions. And some of this is going to be important because when we take more complex functions, we can look at these more complex functions as algebraic combinations of simpler functions. But in order to be able to see them in this way, we have to understand how we can create these algebraic combinations of functions. So, if two functions have a common domain or are defined on the same domain, so we can restrict the domain of one of them, if not. Okay, we can add. So we can take f plus g of x, which is equal to f of x plus g of x. So we define f plus g of x as just being f of x plus g of x. We can subtract them. So we're going to define f minus g, the function f minus g, as being f of x minus g of x. We can, quote, reciprocate them. That is not a real word, but we are going to use it anyway. Reciprocate. So we can do 1 over f of x, which is 1 over f of x. So find the reciprocal function. We can divide them, but here we have to be, well, we can multiply. Multiply is not so quite as tricky as divide. So fg of x equals f of x times g of x. Okay, we'll put a little dot just to remind us that we multiply here. We can divide them, but we have a bit of a caveat with dividing. Okay. So we can say that f over g of x equals f of x over g of x when g of x is not equal to 0. When g of x is equal to 0, this is undefined. So f, we can form scalar multiples. So we can multiply by a constant. We call those scalar multiples. So we call that alpha f of x, where alpha is a constant, equals alpha times f of x. And we can form linear combinations. So we can multiply by constants and add or subtract. And we can combine any of these sorts of algebraic combinations if we like. So this is equal to, so you can say alpha f plus beta g of x equals alpha times f of x plus beta times g of x. All right. I'll shrink that down so we get the whole thing. Lovely. Okay, so first example, let's look at a linear combination because all of this other stuff we should have seen before. So, given that we have f of x equals x squared plus 3 and g of x equals negative 3x squared minus x plus 5. Okay, we can find f minus g of x. We're going to find also g over f of x and 3f minus 2g of x. Okay, so the first thing we're going to do is we're going to make sure that these have the same domain. We don't have to restrict them. They are both polynomials. So f and g are both polynomials. They have the same domain. We don't need to worry about restricting the domain. We don't need to worry about the range either. It's okay if they don't have the same range. Okay, so first one, we are going to do f minus g of x. So we're going to take f, so f minus g of x equals f of x minus g of x. So we're going to find f of x minus g of x. So we are going to do x squared plus 3, that's weird too, minus, in brackets, minus 3x squared minus x plus 5. We are subtracting the whole thing of g of x, so we need to use brackets when we substitute. And this gives us 4x squared plus x minus 2. For g over f of x, we don't have to worry. We can note that f, so x squared plus 3, is always greater than 0 for all x element of the real numbers. So we don't have to worry about restricting the domain here to say that f can't be 0 because it never is 0. So g over f of x equals g of x over f of x. So we will take g of x, g over f of x is g of x, which is negative 3x squared minus x plus 5, over, I'll just draw a nice line down there just so we can keep our problem straight. Over x squared plus 3. And now over here we have our linear combination. So we are going to do 3 times x squared plus 3 minus 2 times negative 3x squared minus x plus 5. When we simplify this, we get 3x squared plus 9 plus 6x squared plus 2x minus 10, which simplifying we get 9x squared plus 2x minus 1. So all of that is just little bits of algebra, and generally you will be told what to do by looking at what you are asked right here. What sort of algebraic combination are you being asked to add, subtract, multiply, or divide the whole functions? Be careful and make sure you are subtracting, dividing, multiplying the whole functions, which means in brackets. Okay. So let's find f times g of x. But let's make it a little bit more complicated. What if we have two piecewise functions that are defined everywhere in the real numbers? So we have 2x plus 1 for x's that are less than or equal to 0, and negative x for x greater than 0. That's our f of x. And our g of x will be defined as negative 3x plus 1 for x less than 1, and 2 minus x for x greater than or equal to 1. Okay, so what we have is we have one function that's switching around at 0 and one function that's switching around at 1. So what f times g is going to change at 0, and it's also going to change at 1. So we're going to need to write our product function in a piecewise fashion as well. So let's just take a look at what's happening in our different ranges. So what happens when x is less than or equal to 0? What happens when x is greater than 0 but less than 1? And what happens when x is greater than or equal to 1? These are the three different ranges. So we have f of x. So when x is less than or equal to 0, we are going to be using the yellow function here, and we are going to be using the yellow function here, because less than or equal to 0 means we're also less than 1. So our f times g of x is going to equal 2x plus 1 times negative 3x plus 1, which when we expand our brackets, we get negative 6x squared minus 3x plus 2x is minus x plus 1. So now what happens when we're between 0 and 1? So we've gotten bigger than 0. So for this region, we are going to use x greater than 0. So we're going to use negative x. But we're still less than 1. So we are going to keep using that same function for g. So now our f times g of x, fg of x, is going to be equal to negative x times negative 3x plus 1, which gives us 3x squared minus x. And now, as we get bigger than 1, we have our x greater than 1 here. So this is going to be the same because greater than 0 is also greater than or equal to 1. We're going to be still in this as we get greater than or equal to 1, we're going to keep the same function for f of x, but g of x is now going to change to be that function. So we have now f times g of x equals negative x times 2 minus x, which gives us x squared minus 2x. Okay, so now I'm going to have to, we have 3 different quadratic equations for our f times g of x. So our f times g of x, we are going to need to define piecewise, as we did with our original functions, except this time there are 3 pieces. So we have our first one, which is negative 6x squared minus x plus 1 for x less than or equal to 0. We have our second function, which is 3x squared minus x when x is between 0 and 1. And we have our final function, which is x squared minus 2x when x is greater than or equal to 1. And that would be how we would write our solution. And so there are many more different kinds of algebraic combinations of functions you can do. Go and have some experiments. Like I said, sometimes we're going to be thinking about doing algebraic combinations. Sometimes we're going to be thinking about breaking them down as we get further into calculus.